Hi everyone. Now let's create a Kafka consumer module under Kafka folder and add app-config data, Spring Kafka, and our dependencies. Then we need to add a Kafka consumer config data class with the configuration properties Kafka consumer config and again with configuration and data annotations as we did in previous config data classes. Then let's add the required properties. We will be setting values and explaining these properties when we are writing to the configuration file. So let's create config client Kafka to Elastic YAML file under config server repository folder. In this file, we will set our configuration properties for the Kafka to Elastic service. First, let's set a port for the previous service as 8181 to change the default one, which is 8080. And for this current microservice, we will set the port as 8182 to prevent port conflicts. I will first add Kafka config and retry config definitions as we did in the previous microservice. And here we need to add additional prefix called kafkaconsumer config, which will populate an object of class kafkaconsumer config data we just created. Let's now insert the properties for kafkaconsumer config configuration and then go over one by one to explain each of them. Key and value deserializers. Since we will read the data from Kafka topic, in the consumer, we need deserializers. To read key, which is long, and to read value, which is the same aura type that we defined in the producer serializer. Consumer group ID. This property ensures that we do not start from beginning each time, but instead an offset remains for the last read item. Auto offset reset. With the auto offset reset earliest, we say that we want to start reading from the beginning of a partition. Specific aura reader. Since we work with aura type, we have to set this aura reader property to true in the consumer config. Batch listener. This property allows to consume the data in batches. Auto startup. We want to start listening from topic after checking the topic is already there, so auto startup is set to false here. Rather, we will start listening explicitly as we will see in the coding section. Concurrency level is set to 3, which is equal to the partition number, and it is required for maximum concurrency and higher throughput. Session timeout milliseconds. This property is for heartbeat threads and specifies the amount of time within which the broker needs to get at least one heartbeat signal from the consumer. Otherwise, it will mark the consumer as dead. The default value is 10 seconds. Heartbeat interval millisecond. This one specifies the frequency of sending heartbeat signal by the consumer. So if this sets to 3 seconds, which is the default value, then for every 3 seconds, the consumer will send the heartbeat signal to the broker. It is recommended to wait for missing some heartbeat signals before marking the consumer as dead. So that's why we set the heartbeat to 1/3 of the session timeout milliseconds, so that it will try 3 times before timing out. Max ball interval milliseconds. This property is for user threads. If message processing logic is too heavy to codes larger than this time interval, coordinator explicitly have the consumer leave the group and also triggers a new round of rebalance. This value should be set according to the processing time requirements. Max poll records. This property sets the maximum records to fetch in each poll. Max partition fetch bytes. This is the maximum bytes to fetch in each poll. And finally, poll timeout milliseconds. This property determines that how long we will wait until at least one record is available. It will block in the poll method on Kafka consumer and wait this time for the new records. Setting this value to too high will block too much, and setting it to too low will cause CPU stall. Having explained these values, let's now create Kafka consumer config class. We will first create a package com microservices demo Kafka consumer config, and then create a class Kafka consumer config. We will mark this class with configuration annotation, and additionally, we will also use enable Kafka annotation, which will enable detection of Kafka listener annotation. We may skip to use this enable Kafka annotation because Spring Boot will automatically enable Kafka listener annotation, but for a Spring application, you will need to use this annotation. Now we will use two generic variables here again, with k extend serializable and v extend specific record base for key and message for the Kafka data. We will then inject Kafka config data and Kafka consumer config data objects to the Kafka consumer config class. Then start writing some beans as we did in the producer configuration. We first need to create a map string object with a method called consumer configs. We will fill these properties in a minute. Next, we will create a bean called consumer factory to return a default Kafka consumer factory, which will take consumer configs as parameter. And finally, we will create a Kafka listener container factory, which will return a Kafka listener container factory class with a generic parameter concurrent message listener container. And inside this method, we will create a concurrent Kafka listener container factory and then set a consumer factory by reading from the consumer factory method. And additionally, set batch listener, concurrency, auto startup, and poll timeout properties by reading them from the Kafka consumer config data object. With batch listener, we are saying that we want to get data from Kafka not one by one, but as batches. And with concurrency level, Spring Boot will create that much threads when consuming data. And this should be equal to the partition number, as we mentioned previously. With auto startup, we are saying that we want to start immediately when the application starts, or we will trigger the start later. And finally, poll timeout will set the poll timeout property, which determines how long we will wait until at least one record is available when we call the poll method. Let's finally populate the consumer properties in the consumer configs method. We will read bootstrap servers first from Kafka config data. Then we read the Kafka consumer config data properties that we created in the application configuration. So we set key and value deserializers, group ID config, auto offset, schema registry URL key and value, specific Avro reader key and value, session timeout milliseconds, heartbeat interval milliseconds, max poll interval milliseconds, max partition fetch bytes, and finally max poll record configuration. Here we get the keys in the properties using consumer config class, and then get the constants inside this class. And the values are coming from the application configuration using the Kafka consumer config data. Alright, I will see you in the next section.